Each pallet is registered immediately, so lot identity stays attached to the raw material from dock to dispatch.
Gross weight is captured before release, so inventory, yield, and mass balance can be verified later.
Paperwork review screens out obvious mismatches before labor and utilities are spent on the lot. Quarantine prevents unapproved produce from mixing with released material on the main line.
Surface condition indicates harvest handling quality and predicts the cleaning load required downstream.
Recording these, it influences microbial control strategy and final product standardization.
Log measured pH result.
Intake temperature shows how well the cold chain was maintained before the product reached the plant. Inbound criteria is physically separated, so it cannot accidentally join the approved process stream.
Normal line release ensures only
Controlled crate presentation prevents product shock and keeps raw material feed steady into washing.
A controlled tipper transfer feeds the line efficiently while minimizing impacts that can create trim loss later.
even feed spacing improves debris removal and gives the wash system consistent hydraulic loading.
Early debris removal protects pumps and wash water quality before the produce enters the main flume. Flume begins wet cleaning and gentle transport, moving the crop without harsh mechanical abrasion. Bubble agitation loosens adhering soil while keeping the whole bulbs moving toward the next wash step.
Controlled turbulence exposes the full bulb surface, so soil can detach evenly before sanitizer treatment.
The lift-out step removes the crop from recirculating wash water and prepares it for fresh spray rinsing.
A freshwater spray removes suspended dirt, so contamination is not simply redistributed across the lot.
We verify the sanitizer dosing flow, ensuring the pump is running and the line is feeding the wash system.
Check sanitizer concentration.
The contact section is designed to deliver measurable exposure time instead of a brief, uncontrolled splash.
Residual chemistry and suspended matter before inspection and trimming.
Effective drainage lowers carryover, so the next inspection zone stays cleaner and easier to control.
Dewatering improves visibility for inspection and prevents unnecessary dilution of the puree later on. Clean drainage is part of sanitation design because standing rinse water can spread soil and microbes across zones.
Single-layer presentation is essential because defects hidden under overlapping produce are easily missed.
Manual rotation complements automated sorting because irregular vegetables can hide defects in shaded recesses.
Optical sorting adds repeatable detection for color defects and contamination that manual checks can miss at line speed.
Material continues to trimming, reducing wasted labor and protecting yield on the main line. Improves cut quality and prevents sudden surges into the size reduction equipment.
Controlled feeding starts size reduction while keeping operator contact away from the cutting zone.
Pre-slicing makes the feed more uniform for the grinder and reduces sudden torque spikes in the next machine.
Byproduct stream is separated at the moment it appears, so only suitable slices remain on the main puree route.
Uniform slices feed more steadily than whole bulbs, improving particle size control at the grinder. Grinding breaks the tissue structure, so the pulper can separate edible puree more efficiently in the next step. A small buffer stabilizes the feed rate, so the pulper receives a consistent mash load instead of surges. Controlled pump feeding prevents cavitation and keeps the pulper supplied at a steady rate. Closed sanitary transfer limits exposure and keeps the mash moving cleanly into extraction. The pulper begins separating softened edible tissue from coarse, insoluble material in a controlled mechanical step.
This first extraction step recovers usable pulp while pulling out larger, insoluble fragments that would hurt texture.
Coarse residue is removed immediately, so it does not re-enter the edible pulp stream.
Visible segregation protects the edible stream and keeps the fiber byproduct traceable from the moment it separates.
The finisher refines the pulp further by removing smaller fibrous particles that escape the first extraction stage. Stable, uniform flow confirms that upstream grinding and finishing are delivering the expected consistency. Final sieving removes occasional remaining coarse particles before the puree enters closed tankage. Screening protects downstream valves and helps deliver a uniform puree texture to the aseptic line. Deaeration is introduced after fine screening, so entrained air can be removed from a more uniform puree. Removing entrained air improves pump stability, limits oxidation, and supports more reliable downstream heat transfer. Stable outflow from the deaerator prepares the puree for controlled buffering and later standardization. Buffering decouples upstream extraction from downstream standardization, so small speed changes do not disturb the full line. A stable operating level helps smooth flow to the blend section and protects pumps from frequent stop-start cycling. The fiber byproduct is dewatered separately to prepare it for drying and milling without any return to the edible stream.
Mechanical dewatering lowers dryer load, and the expressed liquor is treated as wastewater rather than reused in product. Even bed depth improves drying uniformity and reduces the risk of damp pockets before milling.
Drying stabilizes the fiber byproduct so it can be stored and milled without microbial growth or clumping. Milling converts the dried fiber into a more uniform powder that is easier to sieve and bag consistently. Sifting removes oversized particles, so the byproduct powder leaves this side stream in a controlled specification range. Is essential because a sanitary aseptic line depends on measured cleaning performance, not appearance alone. Measured conductivity and return clarity confirm the cleaning cycle has completed to the plant standard before food contact resumes. Once the cleaned circuit is released, the buffered puree can move forward into controlled standardization. The blend tank provides a controlled point to standardize the puree before final heat processing.
Controlled volume and gentle agitation help keep the puree uniform before measurements and adjustments are made.
Validated target because microbial safety depends on actual delivered temperature, not just a set point entry.
The holding section delivers the required exposure time, which is the heart of this critical control point.
The diversion valve protects the line by allowing only product that meets the validated conditions to continue forward.
Controlled cooling stabilizes the treated puree before it enters the aseptic side of the line.
Short filler speed changes while protecting the sterile boundary of the treated puree. Connect sterile drum liner. Correct nozzle positioning limits splashing and helps preserve sterility inside the drum liner during fill. Steady fill rate supports accurate net weight and minimizes disturbance inside the sterile package. Immediate closure preserves package integrity and protects the sterile product from recontamination. Coating, net weight verification, and seal inspection complete the traceability and package integrity checks before dispatch. Stable pallet formation protects package integrity and keeps the finished lot organized for warehouse handling.